Hello and welcome to another episode of Momento Malum today. In this episode, we'll be talking about the pedigree and founder effect within Indian chickpea germplasm, specifically modern varieties. Let's get started. The chickpea is a crop that's cultivated in more than 50 countries spread across Asia, Africa, the Americas, Oceania, and Europe. As of the writing of this paper I'm citing, which was written in 2016, the chickpea was the most important crop in India. Of the total pulse production, which would be chickpeas, lentils, peas, fava beans, etc., of that category of crop, 48% of that category consisted of chickpeas, and 97% of the exported pulse crop consisted of chickpea as well. Among crops, chickpeas has the longest history of breeding within India, starting off with improvement of pre-existing land races through selection and the development of genetic lines within said land races to create new cultivars. This was swiftly followed by systematic breeding programs through hybridization to create cultivars that have both short season qualities and high levels of disease resistance, and a suitability for late sowing conditions, with later applications of high response to high input environments. As market demand changed, the shift became to breeding large-seeded varieties like the Kabuli type chickpeas, a similar pattern found in most other bean varieties throughout the world. Despite these advancements, productivity when it comes to chickpea is still relatively low within India, at least as of the writing of this paper. This is a direct consequence of the shallow gene pool of the modern cultivars of chickpea within India, and various NGOs are attempting to improve or ameliorate this problem. One such group is the ICAR, of which this paper comes out of. This paper is an attempt to assess the genetic base of chickpea within India through pedigree analysis. This was done through genetic analyses done on 138 chickpea varieties developed through the hybridization practice. These were acquired from the organization Central Variety Release Committee and the State Variety Release Committee. The resulting tables were released on the last two slides of this video, made from screenshots from the paper itself. But first, let's cover the results of the paper itself. Hello, I just want to let you know, if you want to fund this channel, you can do so on the platforms seen in the description below. Amongst the cultivars released in India until 2013, 22% of these cultivars were developed through direct selection from the landrace specimen, 6% were derived from mutation breeding, and the remaining cultivars were made through hybridization, followed by selection. During the initial years of chickpea improvement, different selections were made from different land races across India itself, specifically selecting single plants from the land races found in different regions, and then selectively breeding those lineages until they reproduced true to type. Some of the important foundation cultivars made from this process was the varieties C235, G24, S26, C104, Type 1, Type 2, Gwalior 21, Ujjain 21, Jaffa, Anigiri 1, RS10, ST4, BR75, and Type 3. Still other samples were obtained from the wild species, both the direct wild ancestor of the common chickpea and their close related species. Crossbreeding between the wild species cultivated form led to several different cultivars, including P9847, NEC206, Rabbit, and P827, as well as multiple other cultivars. Within India, 138 chickpea cultivars were released for cultivation across the different regions of India proper, and were developed through hybridization. The pedigree analysis of these chickpea varieties revealed that their origin can be traced back to 160 parents. Among these cultivars, 99 of these ancestors have been used only once, while 19 of these parent cultivars have been used twice, but only a small number of cultivars have been used multiple times across many varieties. The most frequently used parent utilized in the development of chickpea cultivars was rabbit, which was found in the pedigree of 37 of the 138 cultivars, closely followed by PB7, which begat 36 cultivars. IP58 is in the pedigree of 32 cultivars. C1234 is in the pedigree of 32 cultivars as well, and S26 is in the pedigree of 27 cultivars. The cultivars Rabbit and PB are in the pedigree of over 26% of all Indian varieties. C1234 is in 23.29% of all cultivars, as is IP58, and S26 is in 19.57% of all cultivars. The pedigree of these frequently used parents are the product of the fact that the initial crosses are used to crossbreed with other plants to create new varieties, creating a direct line of lineal descent for a great many cultivars. This is a direct product of the increasing complexity of the crossbreeding operation and elite with elite. The broadening of the gene pool, however, has also become a great deal more common within the breeding process. For instance, one of the most recent varieties of chickpea in India, Ujjawal, is derived from 15 different parents, extending across 7 generations. As of right now, of all the cultivars derived from hybridization, which are the predominant cultivars used in commercial production, 50% of the genetic base comes from 28 parental lines, with the cultivars Rabbit, PB7, and JG62 contributing 10% of all genes to these 50% varieties. This narrow pedigree has increased vulnerability to the various problems found in a volatile climate such as India, and there has been a reduction in tolerance to both biotic and abiotic stresses within the Indian chickpea gene pool. And the researcher recommends the use of wild species and going back to basics through selection of different specimens from the land races to further broaden the gene pool and improve the durability of the modern cultivars. And that will cover everything. Thank you for watching.